Hi everyone. So the goal of this video is to understand net force in two dimensions. So we've seen net force before if you've watched the previous videos, and this is just building off of that idea. Also building off of some ideas that we talked about in the beginning of the year when we talked about vectors. So as usual, try to find a good spot to watch this video. Use of headphones is suggested, and if I ever talk too fast or too slow, you can change the playback speed in the bottom right in the settings. All right, so this is just an example from a previous video, but I want to quickly go over it, just quickly go over free body diagrams, net force, things like that. So I'm just going to quickly draw this object. I'll draw a free body diagram really quickly, and then we'll talk about the net force, and we'll talk about how that's calculated. So we have 30 newtons north, we have 60 newtons east, we have 30 newtons south, and then we have 20 newtons west, something like that. Trying to make the arrows kind of proportional. It's not perfect, but that's okay. All right, and then if I was going to try to find the net force, a very important idea here is that we cannot add up the forces that are not in the same plane. Or in other words, we can only add up the forces in the x direction, and then we can only add up the forces in the y direction, but we can't just mix and match. So the first thing I'm going to do is I'm going to add up all the forces in the x direction. So I have 60 to the east, but then I have 20 to the west. So I would end up doing 60 as a positive number, but then 20 as a negative number. So I really just end up with 60 minus 20. And so my net force in the x direction would be 40 newtons. Now on the other hand, with the y direction, I have 30 newtons north, but I also have 30 newtons south. So those two will just cancel out. And so the net force in the y direction is just 0. All right, and then we can kind of just stop there. Now, as you might see in future problems, though, things might get a little bit more complicated. For example, what if there was a net force in the y direction? Then you have two net forces. What can you do with that? And that's kind of the point of this video. So we can't just add them up. If we have forces in the x and the y direction, we can't just add them up, but we can use trigonometry to find the resultant force. And force is a vector, so we can use trigonometry just like we did when we talked about displacement in two dimensions. So we talked about displacement. If somebody walked, 5 meters to the west and then 10 meters north, how far did they go? What is their displacement? Well, we can use some of the equations that you see on the bottom of the screen to find the resultant. And we can do that same exact thing with forces. So here's an example, and I try to put the equation up here on the side. So this one is very similar to the problem that I just showed you, but we're going to find that there's actually two net forces. There's going to be a net force in the x direction and a net force in the y direction. So let's quickly just draw this, and we'll try to draw it proportionally, and that will give us a good idea of what kind of forces we're dealing with here. So we have 60 to the north, we have 60 to the east, we have 30 south, and then we have 20 west. All right. And so what you might be able to tell from this picture is, well, if these are the forces, and if I were really trying to figure out, okay, if I'm trying to figure out which way is this object going to move based on the forces, well, most of the force is heading in the upward direction and the rightward direction. So I bet the net force should be something in this area, something kind of like that. But we're going to use a little bit of math to kind of show that that might be true. All right, we're going to use this equation over here. Once we find the net force, we can use this equation to find the resultant force. So let's try to find the net force really quickly. So just like last one, we'll do net force in the x. Well, we have 60 to the east minus 20 to the west, so 40 newtons. That one's actually the same as the last problem. But as you can see, we have a net force in the y direction now. We have 60 to the north and 30 to the south. So 60 is positive because it's north, 30 is negative because it's south. So I end up with 30 newtons south. So now I have two net forces. And so this is where this equation comes in, where I have an x and I have a y, and I can find the resultant force. So you can kind of imagine this as a right triangle, just like what we did with displacement, right? We could say, okay, I have this number here is like a 40, and this number here is like a 30, and I'm trying to find what is this number here? What is my hypotenuse of my triangle? And so we can plug that in to this equation. So the x here would be 40. So I would have 40. See if I can draw this well. Well, let's see if I can draw it, period. So we have 40, and this is going to be squared, plus 30 squared. All right, and then it's very important for me to square root this whole thing. All right, so that is my very beautiful drawing here. Okay, let's just make sure we have our square root symbol going over this whole thing. All right, and now if you do the math here, 40 squared, that's going to be 1,600. 30 squared is 900. You add those together, you get 2,500, and you should end up with a square root of 50. All right, so we could say that the resultant force is 50 newtons. You can even take it a step further, and you can find what is the angle. So let's say we wanted to find this angle in here. We can find that out pretty easily, right? Just using some trigonometry. We know that this is 40, right? We know that this is 40. We know that the other side is 30 over here. And you can use some trigonometry to figure out the angle here. All right, we know that the tangent of an angle is opposite over adjacent. So this is the opposite. So 30 would be considered the opposite, and 40 would be considered the adjacent. I might make like a quick supplementary video in case anyone wants to get into the trigonometry, but we have 50 newtons is our resultant force. All right, and I'll give you one other example. So what if you have a force and it's applied at an angle? What if you were trying to figure out the x and y components? So just like when we talked about displacement, you can break it down into x and y components. So let's say you have some kind of force being applied at an angle and you just want to know the x component. We can use this trigonometry setup here where you have your force and then times cosine of an angle. Now here I'm showing you d as displacement because that's something that has looked familiar before, but really we're using the same equation, but we're just going to use F here for force. So let's do a quick example here. So let's imagine that a kid is pulling a sled over the snow, and the kid is pulling with a force of 30 newtons at an angle of 30 degrees. How much of the force is used to actually move the sled over the snow? In other words, what is the x component of his force? So if I was going to try to draw this, let's see if I can draw this. I'm not sure if I can draw a sled, but I'll just draw like a long object here. Okay, and then we can imagine that maybe he's got some kind of string or some kind of rope and he's pulling it at a 30-degree angle. All right, so we know that this force is 30 newtons. All right, so we know that this is 30 newtons right here. So we know that this is 30. Let's see if I can draw that. So we have 30 newtons of force here, and we know that this angle right here, that angle right here is 30 newtons, or sorry, 30 degrees. So now we can do a little bit of math here, and we can find what is the x component of that force. So from the previous slide, we said that the x component is equal to force times cosine of your angle. So I'll just put an angle here. So for us, we would say x is equal to 30 cosine 30. All right. Maybe I should use different numbers, but this 30 is the force, and then this 30 is the degrees. All right, and if you put this into the calculator, you would be able to get your answer pretty quickly. I think cosine of 30 is like 0.866, so that times 30 should be like 23 or something like that. So you can imagine that maybe the force that's actually going to help this sled move is 23 newtons. So you can imagine that he's pulling, but if he's just pulling up, that doesn't really help him move the sled across the snow. The only thing that really helps it move is any force that he's applying in the x direction. So that's why it's useful in this situation to know just the force in the x direction. All right. So I think I'll stop there and maybe I'll give you guys a few practice problems to try. Again, it really just comes down to these two tricks. If you don't know your resultant force, then you want to use your x and y components to find the resultant force. If you know the force and an angle, you can break it down into x and y components, where x is based on the cosine of the angle and y is based on the sine of the angle. So I hope that helped. Maybe give a few practice problems a shot. Again, this will be more of a should do or an aspire to assignment, but I hope you guys give it a shot.